Alright, welcome back. In this lecture we're going to go over some more MATLAB basics, but more specifically we're going to go over matrices. We're going to learn how to create numeric matrices in MATLAB, perform basic matrix operations, and write mathematical expressions using functions on an entire matrix. So how do you define a matrix? Well, a matrix or an array consists of numbers organized into rows and columns. The size is given by the number of rows by columns. It's usually what I forget in MATLAB. I kind of tend to think it's columns by rows, but it's rows by columns. You define a matrix the same method as you would use to define a vector. It's built row by row, not column by column, because again, MATLAB works row by column. So a comma or space means go to the next element in the current row, and then a semicolon means go to the beginning of the next row. For example, if you were to type M1 equals bracket 0 minus 3, 3, semicolon, minus 2, 6, 0.2, you would create the 2 by 3 matrix M1 that contains 0, minus 4, 3 in the first row, and minus 2, 6, 0.2 in the second row. You can also use indexing to create matrices. You need to list the row and then the column. The first is the row, the second is the column. Again, it's row, column. Unspecified elements are automatically set to 0. So what happens if I form a matrix by the following commands? I say M3 of 1, 1 is 5, M3 of 2, 1 is 0, M3 of 1, 2 is 1, and M3 of 2, 2 is 8. Well, it's going to create a 2 by 2 matrix because my first index only goes to 2 and my second index only goes to 2. The first one was row 1, column 1, so it puts a 5 in there. The second one was row 2, column 1, so it puts a 0 there. Then I have row 1, column 2 was 1, and row 2, column 2 was 8. You can use a semicolon in a similar way as you did to define vectors in order to define matrix. So say I had the previously defined matrix M5 as shown, and I say M5 of 1, 2 to 3 is equal to minus 1. What that's going to do is it's going to set the second and third columns in row 1 to minus 1. You can define another matrix. You can define a matrix from a previously defined matrix. So again, if I have my matrix M5 defined as shown, and I say M6 is equal to M5 of 1, 2, 2, 3, that's going to create matrix M6 of rows 1 and 2, columns 2 and 3. So M6 is going to consist of minus 1, 0, 55. If you want to extract an entire row or an entire column, you're going to use the colon function in MATLAB. So if I type in M7 is M5 of colon, 2, that is going to take all rows in column 2. So M7 is equal to minus 1, 0, 88. You can use the colon to force a vector definition to be a column instead of a row. So say I wanted to create a vector and I wanted it to be a row vector, I could technically say that C2V of colon, 1 is equal to 1, 4, 3, 7. I'm saying that all rows in column 1 are equal to this. And this is what would appear if you typed in that line of code. You can delete rows and columns from a matrix, just like we could delete elements from a vector using your empty square brackets. So if you wanted to delete the entire second row, you can say M9 of 2, colon equals square brackets. That's going to take the entire second row because it's going to delete all columns in row 2. M9 would be left with 3 minus 9, 14, 44, 5, 1. You can delete single entries in a matrix, so I can say that M10 of 2 comma 1 is square bracket, so I'm saying delete row 2 column 1 with an empty matrix. It's going to lead to an error because all of the rows of a matrix must have the same number of columns and rows, so you can replace it with a single element 0 by saying M of 2 comma 1 is 0. So you can't use the square brackets on a single element, you can only use them on an entire row or an entire column. You can transpose a matrix just like you can transpose a vector. So what it does is it switches the rows and columns. So if we have an original matrix of 0, minus 4, 3, minus 2, 6, 0.2, and I transpose it using the apostrophes, it is going to switch the rows and columns. So it's going to become 0, minus 2, minus 4, 6, 3, 0.2. So let's assume we have these variables defined in MATLAB already. What is the line of code we would type if we wanted to replace the second row of C into a variable Q? Well, I would say Q is equal to C. I want the second row, so C of 2. And I want all columns in that row, so comma colon. You can have addition and subtractions of a matrix. You can have a scalar, so a scalar is added or subtracted to each element. And you can add two equal size matrices where the corresponding elements of the two matrices are added or subtracted. Otherwise, it will result in an error, much the same way that it did with vectors. So D1 is equal to 7 minus example EXM1. It's going to subtract 7 from every element. It's going to say 7 minus every element in our variable EXM1. If we did E1 is equal to EXM1 plus EXM2, we're going to get an error because our matrix dimensions do not agree, because EXM1 is a 2 by 3 and EXM2 is a 2 by 2. We have multiplication. Again, you can have scalar multiplication of a matrix where scalars multiply by each element. You can multiply two equal size matrices by using element-wise multiplication using the dot, using our element-wise operator, the dot before our multiplication sign. Or you can do true matrix multiplication where you multiply matrices of two different sizes. Unless my survey indicates otherwise, this is not going to be covered in this course because it is above the current math level of the majority of the students. What you would get in these examples, if, for example, if I do 3 times EXM1, it's going to multiply every element in EXM1 by 3. If I try to multiply EXM1 by EXM3, it's going to give me the error using the multiplication sign, inner matrix dimensions must agree. That is because I'm trying to multiply a 2 by 3 by a 2 by 3, and the laws of linear algebra say that you can't do that. The inner number must be the same. So you would have to put your dot in there for element-wise multiplication for that line of code to work. Again, you can raise a matrix to a scalar. You can by using the element-wise multiplication symbol. You can raise a scalar to a matrix by using, again, the element-wise multiplication symbol. You can do a matrix raised to an equally sized matrix, again, using our element-wise operator. You can do a square matrix raised to a positive integer is not element-wise, it's not covered, and it requires full matrix multiplication. So we're going to try to avoid that. As an example, we have these predefined matrices, again in MATLAB, but we're trying to write a single line of code. We want to square each element of C and place the result in P. So I want to say P is equal to C dot caret 2. and that will square each element in C. If I had not put that dot in there, MATLAB was going to perform an operation of C times C, which is full-blown matrix multiplication, which I am not covering. You can divide a matrix by a scalar, and each element of the matrix will be divided by that scalar. You can divide a scalar by a matrix by using our element-wise operator, and you can divide a matrix by an equal-sized matrix, again by using our element-wise operator. You do not divide a matrix by another matrix. That's not even a form of math that exists. The same goes for vectors. Vector division and matrix division aren't real. Again, the type of math that exists to work around that is not covered in this course. So our example of Q1 equals EXM2 divided by 4, we'll take every element in EXM2 and divide that by 4. So if I wanted to do Q3 is 10 divided by EXM1, I'm going to get an error because, again, the inner matrices dimensions do not agree, so it is not possible. I forgot my element-wise operator. So what are some functions that are used with matrices? So all of the previous functions that I've introduced also work with matrices. However, some might not work in the way that you expect. Size determines the number of rows and columns in a matrix. It's very useful. Find finds the indices of all non-zero elements in a matrix. Again, this is also very useful. Zeros creates a matrix of all zeros depending on the size that you give it. Ones creates a matrix of all ones. I creates a matrix with the number of rows and columns where the elements are 0 except for the main diagonal, which consists of ones. Rand creates a random matrix of numbers. Diagonal specifies or extracts diagonals of a matrix. Trace actually gives you the sum of the elements on the diagonal. Flip up flips the matrix in the up or down direction. And then we have flip low, which is flip LR, which is for flip left right. We have rotate 90 to rotate at 90 degrees clockwise. For example, if I have these previously defined matrices in MATLAB, what's going to be displayed if I type xy is equal to the size of b, and then d is equal to b11 space c of length c of minus 1, and then b of xy. So let's go through these one by one. Well, first, xy equals size of b is going to determine the number of rows and columns in b. So b has 3 rows and 3 columns. So x is going to equal 3 and y is going to equal 3. So then d is equal to b of 1, 1. So it's saying go to matrix B, column 1, row 1. So that's 10. Then it's saying c of, well, it wants to go to the length of c minus 1. So how long is c? The length of c is 3. Minus 1 is 2, so what's the second element of c? And the second element of c is 25. And then it wants the value of b of x of y, which is 3, 3. So I'm going to go to row 3, column 3, and it's 80. So I hit my button to display the answer to see if that was right. And it was. D contains 10, 25, 80. Let's work on another one. What will be placed in the variable j by the following code? So c is equal to the length of h, and j is defined of equal to h of 1, h of c, then h of c minus 3 to c minus 2. So again, let's work by this one by one. C is equal to the length of h, which is 1, 2, 3, 4, 5, 6, 7, 8. So c is equal to 8. So j is equal to h of 1, which is 25. Then h of c, so h of 8, which is minus 52. Then we have a colon, which means go to the beginning of the next row. And it says h of c minus 3 to c minus 2. So that's h of 5 and 6. 1, 2, 3, 4, 5, 64, 55. And there's your answer. I want to create a matrix that is 6 by 6 of all zeros with the major diagonal containing the values of 3. What am I going to write? Well, the first thing I'm going to do is create, there's multiple ways to do this. The one way is to create the major diagonal, which is equal to 1s of 1 comma 6, which is going to create a diagonal of, it's going to create a 6 by 6 matrix with the values of 1s everywhere, and if I multiply by 3 will be 3 everywhere. And then if I'm going to use the diagonal function on measure D to just extract the diagonal and set all the other values as 0. So while you can only fill a matrix with the values of 1s, you can always multiply by a scalar. Another way that I could have done it was define the matrix M1 to equal diagonal and then type in the diagonal that I wished, which are 6 3s as my vector. So to create a 6 by 6 matrix of all zeros with the first row of all 3s and the first column of all 5s except the first row, what am I going to do? Well, first I'm going to create a 6 by 6 matrix full of zeros. So I'm going to use the zero function. So the syntax for that is zeros of 6 by 6. Then I'm going to set the entire first column to 5. So I'm going to say A of all rows in column 1 is equal to 5. Then I'm going to say A of row 1, all columns, is equal to 3. The reason you have to do the column first and then the row is because of the definition of this first number here. So what if we want to create an 8 by 8 matrix of all zeros and then alter it to contain the following values that we see in the picture? The first thing we're going to do is create a vector h, which goes from 1 to 8 because we need to put in rows and columns that are a linear sequence from 1 to 8. Then I want to define b to be a matrix that has a diagonal equal to my vector h. So that's going to put zeros everywhere except for along the diagonal, which will now contain my vector from 1 to 8. And then I'm going to set all of my rows in column 5 to h, and then all of my columns in row 5 to h. And that is how we create the matrix that is shown here. We have another example of b is defined in MATLAB already. We want to write a code to determine the maximum value and location of b. Since this is a matrix, the location must be given as row and column. We want to store this in the variable bmax equals value space row space column. So there's a few different ways to do this. It gets slightly tricky. First, we can find the value and column of the max of b. So the max is going to find the maximum in each column first, and then finding the max of that resulting vector will give us the maximum value in the column. And then if we do it on the transpose of the matrix, because again the max function works in each column, we are going to find the row because I have switched the rows and the columns, and then I can define my variable bmax to be equal to my value, my row, and then my column. You can also do it by, again, first finding the maximum value in the columns by saying max of the max. And then I can find the rows by saying I want the max of my rotated by 90 degrees B matrix. You can go even further. This one uses logic, which we haven't fully covered yet. But I can say V is the max of B, and then I can ask MATLAB to find the row and column for that value in B. So there's some different ways to do things in MATLAB, and your homework is going to explicitly state which ways to do it, and if it doesn't, feel free to do it whichever way you please. So that brings us to the end of matrices. So far we've learned how to define basic variables in MATLAB, scalars, vectors, and matrices. In our next video, we're going to go over the remaining types, which are character strings and structure arrays. After which point we will know the basics, so we're going to look into how to define our own functions in MATLAB and really create some tools that will be able to help us solve problems in our future engineering careers.